In this video I'll be solving Leetcode problem 4, median of two sorted arrays. Given two sorted arrays nums1 and nums2 of size m and n respectively, return the median of two sorted arrays. The overall runtime should be log m plus n, so some kind of binary search. And yeah, let's get it. I'll first try to explain it. So imagine we have this situation. We have this, and we have let's have this situation. So we have 1, 2, 3, 5 elements. We have 5, 1, 2, 3, 4, 5. We have 15 elements altogether. So we know median. First, since we have odd number of elements, median is in those numbers. That's first thing, and median has to be greater than 15 divided by 2, which is 7 elements. Okay, so we need to find 7 elements which are less than median. And how are we going to find it? Well, we can find it by checking how many elements of a smaller array we need to use to find that 7 elements. So is it 0, is it 1, is it 2, is it 3, is it 4, is it 5? That's the first thing. So we will do binary search on how many elements of the first array we will use to find the median. And if we use, let's say, 2 elements from this array, we know we have to use 5 elements from this array. And we also know where the median is because it's a neighboring number. Let's see it on example. So we have here 5 elements. Let's start by using 2 elements. So we are here. Since we use 2 elements, we know we will have to use here 5 elements. 0, 1, 2, 3, 4, 5 elements. Okay, and how do we know that we found median? Well, if we found median, then the number on the left side has to be in the first array has to be less than number on the right side in the second array. So that case is true here, but also the number on the right side in the first array that is supposedly bigger than median has to be bigger than the left element that is less than median on the other arrays. So in this case we see that's not true. So we know that we need to use more than 2 elements from the first array. So we then do next binary search that uses from 3 to 5 elements, and we decide to use 4. So we try 4. 4 is now 4 means we have to use here 4 elements, and we immediately see that that's also not correct because we have 6 and 5. 6 is greater than 5, and that shouldn't be the case. So we know we have to search on this half, and we have only one more case, and that's that we use 3 elements. And when we use 3 elements, then we have to use, okay, should have been here, my bad for the last one, that was even worse. So since we use 3 elements here, we have to use 4 here to have 7 elements. And now so in this case we have 4. 4 is smaller than 5. 4 is also smaller than 6. In this way of doing, since I found 7 elements that are less, I know that median is on the right side. So we have here 8 elements, 1, 2, 3, 4, 5, 6, 7, 8, and median is smaller, and in this case it's number 5. So if we use number 5, we have 2 1s, 2 2s, 1 3, that's 5, and 2 4s, that's 7 elements, and we have 6 7, 9, that's 3 4 5 6 7 elements. So 5 is the correct answer. Okay, let's try to call this up now. So n1 will be length of nums1, and 2 is length of nums2. Since we want to do binary search only on the smaller array, or array of the smaller length, then we will switch the call. If n1 is greater than n2, we will return solve dot this with nums2 nums1. Okay, now we have target number of elements that have to be smaller than median. So target number of elements that's smaller than median is well, n1 plus n2 divided by 2. So if it's 15, it's 7. If it's 16, it's 8. And if we have even number of elements altogether, then we'll see how we can find. Well, let's check that immediately. So the median then will be. Imagine we use just 1 here, so this is the case. Median will be so greater element of these two, smaller element of these two divided by 2, so it will be 4.5 in this case. Okay, so we have target, and we have start will be equals 0. Will be equal n1, I guess. No, n1. We'll check if that will work. So while true, we are testing using test number of elements from the smaller array, which is start plus and divided by 2. And in this case, well, I'll use this because or let's do it without. I'll check. So we test this. When we test, we need to check. So if we use 3 elements, that's 0, 1, 2. So index 2, left of n1 is equal nums1 of, well, test well, test minus 1, that's the value. Okay, so we need to, when we use 0 element, we need to amend that. So if we use 0 elements, then it will be float infinity. Why didn't close? If test is equal 0, else this, but we'll have to use minus so that our checking case is always correct. So if we use 0 elements, then it's minus infinity, else it's nums minus 1 is left, right on the nums 1. If we use all the elements, then it also has to be correct, so it will be float infinity if test is equal n1 minus 1, else, well, if test is equal n1, else it's nums 1 of, again, test minus 1. And similar thing for nums2. So if we use 0 elements, so minus float infinity, so minus float infinity if we use 0 elements, and we use 0 elements if target minus test is equal 0, else we use nums2 of target minus test minus 1. We have to use 2 elements, then left side is this index, okay, and right of this one is equal, so float infinity if we used all elements, so if target minus test is equal and 2, else the same thing. Okay, so these are the numbers we need to check. And now we have first case, so if left in the first array is greater than right in the second array, that means that we need to increase our start to the test. And since test is also not good, I think we need to go to the next one, if I'm correct. So test was not good, we don't want to test it anymore. Yeah, okay. If ln2 is greater than rn1, we have to use wait a minute. So if ln, I don't know, this was bad. So, and if our left side in the first array is greater than the right side, we have to use less element, and if left side is bigger than the right side, we have to use more elements. So start is equal test plus 1, something like this. What if the answer was 5? Would I ever reach 5? I guess not. Or if I go 4, then start will be 5. Okay, I will test it, so this is okay. And in the end, if so it's all good. if we need to continue here. So if we are in this if condition, that means that we passed. So we have found the median, and if this is even, since I just found a target number of elements, whatever it is, so left side is correct, I need to search it on the right side. Okay, so I need to search it on the right side, and if it is odd, I return minimum of some number of, I use test elements, so I guess Rn1, Rn2 should be the answer. And if it's not true, then return max of ln1, ln2 plus min of rn1, rn2, all of them divided by 2. Well, actually not into division, but this division. And that seems it. Let's check it out. So the answer was to use okay. Here I switch sides, so I use this one. This one, first I used 0 elements. If I use 0 elements, my left side is correct. Right side was... Oh, okay, my bad. So can be this. It has to be test. And I guess here also. Yeah, looks correct now and also works pretty nice. So here is log of mn, and space complexity is all of 1, it seems. Let's check it out. Yeah, and 1 and 2. I used mn, all of 1. Okay, hope this was clear. It's pretty interesting hard problem, and yeah. I guess if you have any questions, leave them in comments. I know I already have a video, but since I'm doing NeetCode 150 challenge, I want to do everything again, because I also forget, so it's good to practice. Yeah. Okay. So if you have any questions, you know what to do. I appreciate you following this one. Have a nice day, and see you in the next one.